So if you would, please join me in a warm welcome for Larry Downs.
What I want to do today is pick up on two themes from Bill's talk and give you sort of an outsider's perspective on how those themes are playing out from my vantage point in the self-service universe. In particular, I'm going to tell you three amazing stories from the self-service universe in which surprising results occurred through the deployment of self-service technologies. Now, Bill talked about the convergence of three different kinds of technologies: the point of service, the mobile devices, and then the online channels. And those are very important convergence points I want to talk about. But I think it's important first, before we figure out where that's heading, what the next generation of those technologies looks like, the most important thing to go back to is to look at where this all came from. And just to give you a nice data point, I want to take us back a little bit to 1955, to the sale of the first commercial computer. This is the UNIVAC 1. It had the distinction, among other things, of being the first computer to accurately predict a presidential election outcome ahead of anybody else. Predicted that Dwight Eisenhower would beat Adlai Stevenson several hours before anybody else was able to do that. And it was also used for the first commercial application of information technology, a payroll system for General Electric. Now, many of you, I'm sure probably most of you, are familiar with Gordon Moore's prediction, Moore's law, that says every 12 to 18 months, computing power will double while price will hold relatively constant. That's been the faster, cheaper, smaller principle that's been operating, not really since 1955, but certainly since the mid-1970s. And this is one law that has never been broken. It has operated successfully and accurately every year since Gordon Moore predicted it. One of the things that's hard to understand is, well, what does that translate to? When you have a very small number and you double it, 1 to 2, not really a very big deal. But the longer you continue to double a small number, you start eventually to get to some very, very large numbers. So what's happened here is that we take, and let's just take the UNIVAC and call it a 1. We'll say the computing power of a UNIVAC is a 1. So as we've doubled and doubled and gotten faster and cheaper and smaller over the years, let's move forward now to the year 2000. When Sony introduced the PlayStation 2. Now, this is a computing device, as I'm sure you all know, that was not intended for any kind of a commercial application. It was intended as a game platform for 8 to 13-year-olds, mostly boys, but now increasingly girls. And it was not sold in computer stores. It was sold in toy stores, roughly about $200 retail. The Sony PlayStation 2 would be roughly equivalent in processing power to 22 million UNIVACs. 22 million UNIVACs. And to get some sense of how big that transformation is, if you wanted to buy 22 million UNIVACs in 1955, you would have needed an amount of money roughly equivalent to the GDP of the United States in the year 2000, not adjusted for inflation. Right? Now, that's not the end of the story. Last year, Sony released the PlayStation 2, so I had to update this data. And in the distance between 2000 and 2008, a couple more turns of Moore's law, we go from 22 million UNIVACs, PlayStation 3, roughly 660 million UNIVACs. A little bit more money, but about the same price. Again, no adjustment here for inflation. And again, just to get a sense of where this is all heading, if you wanted to take those 22 million UNIVACs you bought in 2000 and just sort of store them somewhere lined up, you would have needed a space roughly equivalent to the size of the city of Seattle, Washington. If you wanted to take the 660 million UNIVACs that were equivalent to a PlayStation 3, you would need a space the equivalent of the entire state of Washington. Right? Well, that's what our kids have, 660 million UNIVACs. That's what they're playing with. Now, when I first started to talk to executives about how all this technology translated to business applications, and particularly to strategic applications, I found that the easiest way to explain this was to talk about not only Moore's law, but also what, again, a lot of you are probably familiar with, which is Robert Metcalfe's insight, Metcalfe's law, that says as you connect devices, as you connect nodes in a network, as you connect all these millions and millions of computing devices together, the value of those connections increases not at an incremental rate, but at a geometric rate. So as Metcalfe says, the square of the number of users equals the utility of any given network. And that means that network value grows not incrementally, but exponentially. And when I put those two principles together, really, this was when I had my aha moment about 10 years ago and understood that when you took faster, cheaper, smaller, and then networked it together increasingly with open non-proprietary network architectures like the internet, what you had putting them together was the possibility of developing what I called killer apps. And from the very beginning, I understood that killer apps were about, in part, self-service. In fact, we mentioned that there were 12 design principles for unleashing killer apps. The very first principle that we listed was a self-service principle. We said the number one thing you can do with this combination of faster, cheaper, smaller, and network connections is to what we called outsource to the customer. Turn the customer into their own self-service channel. This is a slide I dug up from 10 years ago in the early days, beginning of eBay and Amazon, where we started to see already how cost reduction could be delivered using these technologies and using open network architectures. And in fact, we saw right from the beginning that it wasn't just about cutting cost, it was also about improving brand loyalty, especially where the alternative for the customer was either poor service or no service at all. And you all know what happened to eBay and Amazon over the last 10 years. But even a more basic, another slide that I dug out from 10 years ago was to think about it even in the early days of the banking industry. This was some work that was done by the American Banking Association, again, very early in the days of internet-based banking. What you have, we all know this, is when you take essentially labor and infrastructure and outsource those to the customer, obviously you can achieve some very dramatic reductions in cost. But even from the very beginning, early experimenters using that very profound insight were able to discover new ways of interacting with customers and building new kinds of value and new kinds of relationship. So the other picture on this chart comes from an extremely early application from B of A, again about 10 years ago. It's something they called Build Your Own Bank. It was very simple, but it allowed the customer to customize the interface of how they were going to access the limited amount of banking services that B of A was initially offering over the internet. So right from the very beginning, we understood that self-service was a win-win proposition. Good for you, cost reduction, good for the customer, improved quality of service, 24/7, and then that translating to increased brand loyalty. Well, where this is all heading now, as you heard, is to a convergence not only of devices, but also of applications. And the message for today in terms of technology is it's all about open everything. This includes now increasingly mobile devices, whether they're PDAs, cell phones, laptops, whatever the mobile device is, whatever it eventually emerges to be. These are everywhere, they're ubiquitous, and increasingly they are connected to everything else. It's also taking place on the applications side. You heard a little about what's the so-called Web 2.0, the next generation of software applications on the internet. And these are all about the ability of users to take content and slice it, dice it, remix it, collaborate with each other, and then redeploy it in a variety of new forms, again, based largely on open network architectures, open protocols, and increasingly open source software. So things like Wikipedia, or the social networking applications like LinkedIn, that's the one for adults, the ones your kids use are MySpace and Facebook. These are the kinds of applications that develop when users are given the tools to figure out for themselves what they want to do with the content. Right? And that's where we get to the second theme that I want to pick up from Bill's talk, which is about breakthrough value coming through business transformation. Because what you're going to discover is that as you give, the more tools you give to customers to self-service, the more information you give them, and the more open the architecture in which you deploy those applications, the more positive, surprising results will come. You will discover things about your own business and about your relationship with long-standing customers you thought you knew everything about that, in fact, were completely surprising to you.